According to the National Electrical Code, specifically Section 210.11 Cone, a minimum of 220 ampere small appliance branch circuits are required in dwelling units for the kitchen, pantry, breakfast room, dining room, or similar area. The question arises whether it is permissible to run 12 American wire gauge, abbreviated as AWG, wire to the initial receptacle and subsequently transition to 14 AWG wire for the remaining receptacles on such a circuit. The answer is definitively no. The fundamental principle governing electrical circuit design is that all components within a branch circuit, including the wiring, must be rated to handle the maximum current that the overcurrent protection device, such as the circuit breaker or fuse, is designed to carry. In a scenario of a 20 ampere small appliance branch circuit, every segment of the wiring and every device connected to that circuit must possess a current carrying capacity of at least 20 amperes. The National Electrical Code mandates this requirement to ensure safety and prevent overheating, insulation damage, and potential fire hazards. The current carrying capacity of a conductor, commonly referred to as its ampacity, is directly related to its gauge. The American wire gauge system is a standardized method for designating wire sizes, with smaller gauge numbers indicating larger diameter wires and consequently greater ampacity. Conversely, larger gauge numbers signify smaller diameter wires with lower ampacity. According to industry standards and the National Electrical Code's ampacity tables, 14 AWG copper wire, which is the type typically used in residential wiring, has a maximum ampacity of 15 amperes when used in typical applications with thermoplastic insulation such as type THHN or type NMB cable. This ampacity rating is predicated on specific conditions, including the insulation type, ambient temperature, and the number of current-carrying conductors bundled together. Under no circumstances is 14 AWG wire permitted to be used in a circuit protected by a 20 ampere overcurrent device. To elaborate, installing 14 AWG wire on a 20 ampere circuit creates a significant safety risk. If a fault occurs or the circuit is overloaded, the 20 ampere circuit breaker will not trip until the current exceeds 20 amperes. However, 14 AWG wire with its 15 ampere ampacity is likely to overheat and potentially melt its insulation long before the overcurrent device trips. This overheating can lead to arcing, which is a dangerous electrical discharge that can ignite nearby combustible materials and cause a fire. The purpose of an overcurrent protection device is to protect the wiring in the circuit, not just the appliances or equipment connected to it. Using undersized wiring defeats this purpose and creates a serious fire hazard. When designing and installing electrical circuits, it is crucial to consult the National Electrical Code and adhere to all applicable regulations and guidelines. These codes and standards are developed by experts and are designed to ensure the safety of people and property. Ignoring these regulations can have severe consequences, including electrical shocks, fires, and even fatalities. In the specific scenario presented, the correct approach is to use 12 AWG wire for the entire 20 ampere small appliance branch circuit. According to the NEC ampacity tables, 12 AWG copper wire has an ampacity of 20 amperes when used with typical thermoplastic insulation. Therefore, it is suitable for use on a 20 ampere circuit. By using 12 AWG wire throughout the circuit, you ensure that the wiring is adequately protected by the 20 ampere overcurrent device and that the risk of overheating and fire is minimized. Furthermore, it is important to use the correct type of wire for the application. In residential wiring, non-metallic sheath cable, commonly referred to as NMB cable or Romix, is typically used for branch circuits. This type of cable consists of 2 or more insulated conductors enclosed in a non-metallic jacket. The insulation on the conductors is typically thermoplastic, such as type THHN or THWN. When selecting an NMB cable, it is important to ensure that the cable is rated for the voltage and amperage of the circuit. For a 20 ampere, 120 volt circuit, 12/2 NMB cable is commonly used. The 12/2 designation indicates that the cable contains 2 12 AWG conductors and a ground wire. The National Electrical Code also specifies requirements for the installation of electrical wiring. These requirements cover topics such as wire bending radius, support spacing, and protection from physical damage. It is important to follow these requirements to ensure that the wiring is installed safely and correctly. In addition to using the correct size and type of wire, it is also important to use the correct type of electrical boxes and receptacles. Electrical boxes are enclosures that protect wiring connections and provide a mounting point for receptacles, switches, and other devices. Receptacles are devices that provide a point of connection for electrical appliances and equipment. When selecting electrical boxes and receptacles, it is important to ensure that they are rated for the voltage and amperage of the circuit. For a 20 ampere, 120 volt circuit, receptacles rated for 20 amperes must be used. These receptacles have a T-slot configuration, which prevents the insertion of 15 ampere plugs. It is also important to ensure that the electrical boxes are properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. In summary, mixing 12 AWG and 14 AWG wire on a 20 ampere small-appliance branch circuit is a violation of the National Electrical Code and creates a significant safety hazard. All wiring on a 20 ampere circuit must be rated for at least 20 amperes. Therefore, 12 AWG wire should be used throughout the circuit. Additionally, it is important to use the correct type of wire, electrical boxes, and receptacles, and to follow all applicable installation requirements. Adhering to these guidelines will ensure that the electrical system is safe and reliable. It is also crucial to remember that electrical work can be dangerous and should only be performed by qualified individuals who have the necessary knowledge, skills, and experience. If you are not comfortable working with electricity, it is best to hire a licensed electrician to perform the work. Licensed electricians have undergone extensive training and are familiar with the National Electrical Code and other applicable regulations. They also have the necessary tools and equipment to perform the work safely and correctly. Attempting to perform electrical work without the proper training and experience can result in serious injury or death. In addition to safety considerations, it is also important to consider the long-term performance of the electrical system. Using undersized wiring or improper installation techniques can lead to problems such as voltage drop, overheating, and premature failure of electrical components. These problems can be costly to repair and can also create safety hazards. By using the correct size and type of wire and following all applicable installation requirements, you can ensure that the electrical system will provide reliable and safe service for many years to come. In conclusion, the National Electrical Code is a comprehensive set of regulations that are designed to ensure the safety of people and property. When designing and installing electrical circuits, it is essential to consult the NEC and adhere to all applicable requirements. Ignoring these regulations can have severe consequences. The specific scenario of mixing 12 AWG and 14 AWG wire on a 20 ampere small appliance branch circuit is a clear violation of the NEC and should never be done. Always use the correct size and type of wire for the application and follow all applicable installation requirements to ensure a safe and reliable electrical system. If you have any questions or concerns about electrical wiring, it is best to consult with a qualified electrician. Electrical safety should always be a top priority.